welcome to page 3 of the notes. And what we're going to do is we're going to find the given transformation to evaluate an integral. And we're given what our double integral is, and we're also given what the region looks like. And it also gives us transformation. It tells us that x is equal to 1/4 u plus v, and y equals 1/4 v minus 3u. So let's go ahead and draw what that region looks like. And again, you want to try to be as accurate as possible with this region, just because it's it's really nice when you have everything that's lined up, when you have like your little tack marks to be all equidistant. So like if you're using graph paper, it's really nice. How far on the X? I need to go just that far. So that should be a little bit closer. Alright, so those are about all equal distance. And so I'm going to graph my first point, -1, 3. Let's zoom in there. So -1, positive 3. Then 1, -3. Then 3, -1. And then 1, 5. Make sure that I'm right above that. Looks like I made this just a little bit long. Whoa, too much. Erase these values. No, it's a little too small. It's a good idea just to go ahead and skip to where I actually did this close to being right. So we said 1, -3. 3, -1. And then 1, 5. This is ugly. Alright, so let's go ahead and just connect our dots. So here you see the parallelogram. And now let's find each line. So again, we can denote each line by like S1, S2, S3. S3 and S4. And so I'm going to write out what each equation is. So S1 is going to be the equation. It looks like y is equal to, slope looks like it's down 3/1, so -3x. And it crosses the y-intercept at 0, so it's just y equals -3x. Looking at that, next one, it looks like you have a slope of up 1/1, up 1/1. So you have a slope of 1, so y equals x. So you have a slope of +1. And it's a parallelogram, so these slopes are going to be the same. Not necessarily S1, S2, but S2 and S4 and S1 and S3 are going to be the same. And if it continues along that path, it's going to cross at -4, so -4. S of 3 is going to be y is equal to -3x. So again, that slope. And so if it has that -3 as the slope, then it's going to cross the y-axis at 8. And then S of 4 is going to have, again, it has a slope of 1, up 1/1, up 1/1, and we can actually see where it crosses, sort of. So x plus 4. And so we want to find, where our region's bounded by u and v. So to do that, because the one thing that we can do, so I'll show you this real fast. We can go ahead and write in our double integral. So if I did the double integral real quick of r, I can substitute in, because I'm going to transform this in terms of u and v. I can change 4x to be, it looks like 4 times what our x value is, which is 1/4 u plus v. Let's change those to the box parentheses. Alright, I don't really need that yet. And then plus 8y, so plus 8y, and then we said y is 1/4 v minus 3u. And then we can close that up with that box parenthesis. dA. So it looks like we're going to have the double integral of r. If we do the math right, it's going to be 4u plus 4v. I'm sorry, it's just u plus v. Again, we got to do the math right. U plus v plus 8 divided by 4 is 2, so 2v minus 6u. And so we're going to have the double integral of r, and that's going to be 3v minus 5u dA. And then we can't forget our dA. Our dA is going to involve the Jacobian. So we'll do that in a second. So now let's go ahead and find our region, and then we'll do the Jacobian. So now to find our region, what we're going to do is we're going to take each of these values and we're going to plug in our x and our y to find the low part and to find the high part. So the first one, S1, I'll just denote that right here, is going to be y, which is 1/4 v minus 3u is equal to -3 times, now our x is 1/4 v minus 3u. So the first thing I'm going to do is I'm going to multiply both sides by 4. When I do that, I get rid of these fractions of 1/4, and so I'm left with v minus 3u, and then I can distribute that -3. -3v plus it's -3, so if I multiply by the 4, that's going to be -3, so -3v, -3 making sure that I type or did all this right. V minus 3 is correct, and you didn't write that correct. Alright, so this was u plus v. So that's going to change that. So I'm going to have -3u minus 3v. And the u's are going to cancel out. I can bring, so it's 2v is equal to 0. So we have v equals 0. So that's going to help us with our region. So region 1, or S sub 1, it's going to be v equals 0. So on the graph, it's going to be that horizontal line at 0 on the u-axis. So let's do S sub 2 now. Do the same thing. We're going to plug into y x minus 4. So 1/4 v minus 3u is equal to, in this case, 1/4 u plus v, and then minus 4. Again, multiply both sides by 4. I get v minus 3u is equal to u plus v minus 16, because I have to multiply everything by 4. All right, in this case, the v's are going to cancel out. I can bring the u over. And so I have -4u is equal to -16. And then divide both sides by -4. And I'm going to get u is equal to 4. All right, so now let's find S sub 3. S sub 3 is y equals -3x plus 8. So 1/4 v minus 3u is equal to negative 3 1/4 u plus v plus 8. Again, I want to get rid of that 4, so I'm going to multiply everything by 4. V minus 3u is equal to negative 3 u minus 3 v. 4 times 8 is 32. And then I can get rid of go ahead and get rid of the 3 u's. I'm going to add, so I'm going to have 4. V is equal to 32. Divide both sides by 4, so v equals 8. And then side 4, just go ahead and substitute in y equals, so 1/4 v minus 3u. X plus 4. X plus 4, so 1/4 u plus v plus 4. Multiply everything by 4. V minus 3u is equal to u plus v plus 16. Go ahead and get rid of the v's, bring that here, so minus 4u equals 16. Divide both sides by 4, u equals negative 4. So here we're told that v goes between 0 and 8, and u goes between negative 4 and positive 4. All right? And so again, it doesn't, I can choose what I want first, du or dv. So now I have my region, so now let's just go ahead and find the Jacobian, which is going to be found by dA is equal to, well, let's just go ahead and just find the Jacobian. So the Jacobian is going to be, again, the partial of xy over the partial of, in this case, uv. And so it's just basically the determinant. So the partial of x with respect to u, here I'll write it out because these are notes. Partial of x with respect to u, partial of x with respect to v, partial of y with respect to u, partial of y with respect to v. So we do the Jacobian, and we're going to get, so looking at this, so for x, again, if I take the partial derivative of x there with respect to u, I'm just going to get 1/4. If I do the partial of x with respect to v, I'm going to get 1/4. If I do the partial of y with respect to u, I'm going to get negative 3/4. If I do the partial of y with respect to v, I'm going to get 1/4. So doing the determinant multiply, we're going to get 1 over 16 minus, but it's a negative, so it's going to be plus. So plus 3 over 16, which is 4 over 16, which is 1/4. So our Jacobian is 1/4. So now let's set up the integral. And we'll do this all in green. And so we have the integral. Let's go from, let's do our u's first. So negative 4 to 4. And then our v's, 0 to 8, of what our integral is, 3v minus 5u. And then our Jacobian, which is going to be 1/4. And then we use v on the inside, so dv, du. All right, now let's go ahead and integrate. We did all this just so that we could integrate. And so now we're going to go ahead and integrate. So I can pull the 1/4 out. That's what I'm going to do. Negative 4 to 4, and inside, I can integrate, and I'm integrating with respect to v. So it's going to be 3/2 v squared minus 5uv from 0 to 8. And so it's another good reason we chose that first one to have 0 there. And so we have 1/4 -4 to 4. Plugging in 8 squared, 64, 64 over 2 is 32. 32 times 3 is going to be 96. So we have 96. 8 times 5 is 40, so minus 40u. du. Again, because the second part just gives us 0. Integrate once more. 96 u minus 20 u squared from -4 to 4, and plugging in 4 for that is it's kind of gonna, a lot of stuff's gonna cancel out with that nice little 4 that's in front, but we'll have 1/4. I will say, one thing that you could do here, you could pull out 4s from both of those, and you'd have 24 minus 5, and then you don't have to worry about the 1/4. But yeah, I'm just going to keep it there, and then we'll do the math. So 4 times 96, 16 minus 200 is 192. No, it's not. So 16 minus 400 is going to be 384. Minus 4 squared, which is going to be 16. 16 times 20 is 260. Yeah, I'll just minus, plug in -4, so 384, and then minus 260. It's going to double those, so let's just take half of 384 and half of 260, so that's 130. Let's cancel that out. Give me 192. All right. Sorry for the mental math there. All right, that's it. And that does it for page